Okay, so good morning, everybody. So today we're going to go ahead and go over. Sorry, I just need to adjust the so you guys can see it better. So today we're going to go over number 4, number 5 that I sent to you guys. This is FRQ review for the Calc BC exam. Okay, so let's just jump into it. Hopefully you guys can see that. It seems pretty blurry this morning. Okay, so cylindrical barrel with a diameter of 2 feet collected rainwater. Okay, so this seems like one of those very classic problems of water going in and water going out. Okay, we'll see what happens. As shown in the figure above, the water drains out through a valve not shown at the bottom of the barrel. So there it is. It's going in and it's going out. The rate of change of the height, h, of the water in the barrel with respect to time is given as this. So here is your differential equation that's modeling the rate of change of the height, where h is measured in feet and t is measured in seconds. The volume v of a cylinder with radius r and height h is given as this equation. We're probably going to have to use this, otherwise why would they have given that to us? Okay, A, find the rate of change of the volume of the barrel with respect to time when the height of the water is 4 feet. So we're looking for the change of rate of volume. So we're looking for dV dt. Okay, that's what we're looking for. So if you remember how I always teach this, I say, okay, what do we have? What are we looking for? And then I need an equation that's going to relate V to H. Well, there it is. Okay, now we don't have to really worry about R here because R is going to be constant. This is always going to end up being the same. Okay, so I'm going to go ahead and go up here and try and work right up here. Okay, so what I do is I start off with the volume equation. So volume is equal to pi times r squared h. Now, I'm going to plug in what r is equal to. And the only reason I'm allowed to do that is because r is not changing. Okay, I can plug it in because r is not changing here. So r is going to be, so the cylindrical barrel has a diameter of 2 feet, so therefore the radius is 1. So times 1 squared, I'm just going to leave it out, and then times h. Okay, so that's what the equation comes down to. So taking the derivative of both sides with respect to t, I have dv dt is equal to pi times dh dt. Okay, and then it says, so I need to figure out what this is. So the only thing I need to do is I need to evaluate what dh dt is. Okay, I don't know exactly what dh dt is, but here is the equation right here. Okay, and we need to do this when the height of the water is 4 feet. So this turns into pi times negative 1/10 times the square root of h. Okay, we plug in 4, so this is pi, negative pi over 10 times the square root of 4. So this is equal to negative pi all over 5. Okay, this is 2. 2 goes into 10 5 times, so therefore there's a 5. Okay, now I do need to indicate my units of measurement. So this is the rate at which the height, volume. This is dV dt. So this is the rate at which the volume is increasing or decreasing. So what are my units? I have feet and seconds. And so since it's volume, it's feet cubed per seconds. Okay, so that's what the answer is there. Okay, B, when the height of the water is 3 feet, the rate of change of the height of the water with respect to time is increasing or decreasing. Explain your reasoning. Okay, so when the height of the water is the rate of change of height. So I need to know what is dH dt, what is it doing when h is equal to 3? Okay, that's what I need to know. Okay, oh, hold on. You got to be careful here. It's all in the wording. Is the rate of change of the height of the water with respect to time increasing or decreasing? So it's the rate of the rate, which actually means this is the second derivative. Okay, so that's what I need to evaluate. So the first thing I need to do is I need to go through and figure out what the second derivative is. So maybe go up here. So I have dH dt is equal to negative 1/10 times the square root of h, which I'm going to rewrite as negative h to the 1/2 power all over 10. Then I take the second derivative here. So the second derivative with respect to t, is equal to, so you bring it down, decrease it by a power of 1. So this will be negative 1/20th times the square root of h. Okay, we always talk about the importance of knowing just what the derivative of the square root function is. Remember, it's 1 over 2 root that thing. So 1 over 2 root that thing, 2 times the 10 gives you the 20, and then you have roots. This should be an h here. Okay, so all I need to know is what is this going to be? So I have negative 1 all over 20 times the square root of 3, and that is a value that's less than 0. So what does that mean? This means the rate of change of the height of water with respect to time is decreasing at t is equal to 3. H is equal to 3 because we're doing h is equal to 3 feet. Okay, and then C, so we'll go down below here. Okay, at time t is equal to 0 seconds, the height of the water is 5 feet. So that's where it starts off with. Use separation of variables to find the expression for h in terms of t. So this right here, what they're doing is they're giving you an initial condition where they're saying h of 0 is equal to 5. So that's the coordinate 0, 5. Okay, so I just need to solve this using separation of variables. So we know what to do. We know to get all the h's to the one side of the equation and all the t's to the other side of the equation. If you notice, there are no t's here. So this is going to imply that dh all over the square root of h is equal to negative 1/10 dt. It doesn't matter which side you put this constant on. If you put over there, you're going to get a fine answer. Okay, and now that we've done this, then we integrate both sides. So this is, let me just rewrite this. So this is going to give me the integral of h to the negative 1/2 power dh is equal to negative 1/10 times the integral of dt. Okay, so I raise that by a power of 1. No, I raise that by a power of 1. So it's going to go h to the 1/2 power. Then I divide by 1/2, which is the same thing as multiplying by 2. And this is equal to negative 1/10 times the integral of dt, which is t. And then I still have to have some constant value here. Now the key is, how do you find the constant value here? You have that equation. Okay. So I'm going to have 2 times the square root of h. Well, h is 5. And then minus 1/10 times 0 plus c. So c turns out to be equal to 2 root 5. Okay. Now it says, write an expression for h in terms of t. So you need to actually solve for h here. Okay, so plugging this back in, I have 2 times the square root of h is equal to negative t all over 10 plus 2 root 5. Okay, divide through by 2. So I have h is equal to negative t all over 20 plus the square root of 5. This is the square root of it. And then I just have to square both sides. So h is equal to, and I'm just going to leave it as is, like that. Okay, so that's what our equation for h is going to be. Okay, and that was it. Okay, so next question, number 5. Okay, consider the family of functions f of x is equal to 1 over x squared minus x 2x plus k, where k is a constant. Find the value of k for k greater than 0 such that the slope of the line tangent to the graph of f at x equals 0 equals to 6. So slope of the line tangent, that implies that it's the derivative. Okay, so I'm going to go ahead and take the derivative of this thing. Okay, so I'm going to go all the way up here. So I have f of x is equal to 1 all over x squared minus 2x plus k, which is equal to x squared minus 2x plus k to the negative first power. Now I'm going to use the power rule and then the chain rule. If you wanted to use the quotient rule to do this, it would be perfectly fine. We're going to end up in the same exact location. Okay, so therefore the derivative of f is equal to, bring it down, decrease it by a power of 1, but then by the chain rule, you still need to multiply by the derivative of what's inside here. K is a constant, so that's 2x minus 2. Okay, so that's what it's going to be, and I can even clean this up a little bit more. So I have negative, actually, I'm going to distribute this negative into this, so I'm going to flip it around. So 2 minus 2x all over x squared minus 2x plus k squared. Okay, now I want to know when x equal to 0, what's going to give me a slope of 6. So I'm going to plug in the 0.06 into this. Excuse me. So I have 6 is equal to 2. That's going to go away. That's going to go away. That's going to go away. And I'm just left with k squared. Okay, so what that tells me is k squared is equal to 1/3. Multiplying the k squared up, dividing that down, 2 over 6 gives you 1/3. Okay, so therefore k turns out to be plus or minus the square root of 1 all over 3. Now it does state that k is greater than 0. So therefore I only have k is equal to the square root of 1 all over 3. Okay. B, for k is equal to -8, find the value of the integral here. So go ahead and plug this in. So for B, I have the integral of 1 all over x squared minus 2x minus 8 dx. So you know how to solve this. We have to do partial fractions. So I'm going to come off to the side. I'm going to factor that. So I have, so factors of -8 that up to -2 are -4 and +2. So x minus 4 times x plus 2. And that's going to be equal to some a value all over x minus 4 plus some b value all over x plus 2. Okay, simplifying this, I'm going to end up having, and remember, I don't actually pay attention to the denominators because when I combine these two fractions, the denominators are going to be the same. And the only way you can have them be the same is if the numerators are going to be the same. So I have 1 is equal to a times x plus 2 plus b times x minus 4. Okay, remember then I carefully choose values of x. So I'm going to say x is equal to -2. When x is equal to -2, I'm going to have 1 is equal to, this is going to go away, and here I'm going to have -6. So -6b, so b is equal to -1/6. Okay, and then I go ahead and choose another value very carefully. So I'm going to say x is equal to +4. So in doing that, I'm going to have 1 is equal to 6a, a is equal to 1/6. Okay, so now I can go back up to this and integrate this. So the integral from 1, and this is from 0 to 1, I believe, 0 to 1, of x squared minus 2x minus 8 dx is equal to the integral from 0 to 1 of this, and I'm just going to place in what the a and the b value are. So I have 1/6 all over x minus 4 minus 1/6 all over x plus 2 dx. Now this is the first power, so we know we're going to have a natural log function here. So this is 1/6 ln of the absolute value of x minus 4 minus 1/6 ln of the absolute value of x plus 2. And I need to evaluate this. I don't know if I have room here. I think I do. From 0 to 1. Okay, so I plug in the 1 first. So this is 1/6 ln. 1 minus 4 gives you -3, but we're taking the absolute value. So this is ln of 3. Minus 1/6 ln. Plug in the 1, so you're going to have 3 as well. So those will go away. That's going to be nice. minus, I could plug in the 0. So I have 1/6 ln of 4 minus 1/6 ln of 2. Okay, so you can see that these are going to go away. And so this is going to become, I'm going to distribute the negative. This is going to be the positive, so I'm going to put that in front. So 1/6 ln of 2 minus 1/6 ln of 4, and we are done. Of course, there's some things you can do here to simplify, but I do not need to do that. Okay, okay, C. For k is equal to 1, find the value of the integral from 0 to 2 of f of x dx, or show that it diverges. So I'm thinking that it diverges. Okay, so I'm going to go up here to this page. I have to take on a whole new page here. So I'm going to go from 0 to 2 of f of x, but x is going to be 1, or k is going to be 1. So I have 1 all over x squared minus 2x plus 1 dx. Okay, so I just have to go ahead and integrate this. So what do we notice here? So this is factorable. So this is the integral from 0 to 2 of 1 all over x minus 1 squared dx, which is equal to the integral. Now, here's where you have to be careful. What do you notice here about the value that you would plug in that would make this go away? Okay, it's 1, right? This is going to be 0, and you can't divide through by 0. So what you actually have to do here is you have to split the integral. So I'm going to integrate from 0 to 1 of 1 all over x minus 1 squared dx, plus the integral from 1 to 2 of 1 all over x minus 1 squared dx. You have to split it apart. Now, you still can't plug in 1 here, so I have to change it to a limit. This is becoming quite a crazy problem. So limit as a goes to 1 of the integral from 0 to 1 of 1 all over x minus 1 squared dx, and plus the limit as a goes to 1 of the integral from a to 2 of 1 all over x minus 1 squared dx. Okay, so now I can, wait, this should be an A here. Okay, so now I'm going to go ahead and evaluate. This is just a power rule, right? This is the negative second, so you raise it by a power 1, it's going to be, actually, I'll rewrite it so you can see this. So the limit as a goes to 1 of the integral from 0 to a of x minus 1 to the negative first power dx, plus the limit as a goes to 1 of the integral of x minus 1 to the negative second dx. Actually, I need to address something else too, because of the way that I split this. Okay, so I split it at 1, right? Because I can't plug in 1. But I'm not approaching 1. I'm only approaching 1 from one side, right? This is a one-handed limit. So if you go back up here and I split it here, so I'm going to go from 0 to 1. That means if you look at it like on a number line, so here's 1. And if I'm going from 0 to 1, I'm approaching it from the left-hand side. So this is a left-handed limit. Okay, and on here, I'm approaching 1, but I'm approaching 1 from the right-hand side, so that's a right-handed limit. And it could make all the difference in the world. So this is negative, and this is going to be positive. Okay, so this is going to be the limit as a goes to 1 from the negative direction. Wait, what am I doing? I already integrated. That should be a 2. Okay, so now raise it by power of 1. So x minus 1 to the negative first power divided by negative 1. I'm going to go from 0 to a plus the limit as a goes to 1 from the positive direction of x minus 1 to the negative first power all over negative 1. Once again, going from 0 to a. So this is equal to the limit as a goes to 1 from the negative direction. Okay, so maybe I'll rewrite this first before I actually plug it in. So I have negative 1 all over x minus 1 to the negative first, sorry, that's to the positive first power now, so just that, from 0 to a, plus the limit as a goes to 1 from the positive direction of -1 all over x minus 1, going from 0. I switch these around. I think I switch these around. This should be 2 to a, and this is 2 to a. Okay. Okay, so now go ahead and plug it in. So this is the limit as a goes to 1 from the negative direction of -1 all over a minus 1 minus a negative, so plus 1 all over, when you plug in 0, you end up just getting -1, so that's a -1. Okay, and then plus the limit as a goes to 1 from the positive side of, so now plug in the 2. So I'm going to have -1 all over 1, and then minus a negative, so plus 1 all over a minus 1. Okay, so let's see what's happening here. Okay, so as a goes to 1 from the negative side, okay, so that means it's going to take on values that is less than 1. Okay, half, 3/4, 0.9, 0.99, and so on. They'll all be less than 1. So what that means is this number, a, is going to be less than 1, but it's going to be getting infinitely closer to it. So this thing is going to approach something that's infinitesimally small, but from the negative direction. Okay, let me say that again. So a is going to go to 1 from the negative side. So this is going to go to 1, but it's going to go to 1 as like a half, 3/4, 0.8, 0.9, 0.99, and so on. So this is going to get infinitesimally close to -1 or to this 1, but it's never going to hit it. And so this value is always going to be less than this. So it's always going to be negative, but something that's going to 0, but from the negative side. So if you divide by something that's going to 0, or dividing by something that gets really, really, really small, that makes the thing get entirely huge. So in other words, this thing is going to blow up, and this thing is going to blow up into infinity. Okay? And then this is just going to be -1. So -1. And then plus, now the limit as a goes to 1 from the positive side, well, this would be -1. And then here, okay, so now a is going to go to 1 from the positive side. So right here, this is a is going to get closer and closer and closer to 1. And then you're subtracting 1. So this is going to get infinitesimally small as well, but from the positive side. So you have 1 divided by something gets really, really, really small. So this thing is going to go to infinity as well. So that's going to be plus infinity, and that's bad math. You shouldn't write that, but okay. And so in other words, these are both positive infinities. So therefore, I know that this series is going to diverge. Okay. So it's equal to infinity. So it does not exist. Okay. And there we are. Hope you guys understood that. Okay. Good luck. Only a few more days.